You open Claude on Monday. You explain that you are working on a machine learning paper about protein folding, that you prefer terse answers, and that your co-author's name is Priya. Great conversation. You close the tab. Tuesday, you open a new Claude session and ask a question about your paper. Claude does not know what your paper is about, does not know you like terse, never heard of Priya, because agents have a memory problem. And most of what you have heard about agent memory in 2026 is people trying to fix that. Today, the whole video is memory. What agents actually have, in 4 separate flavors, all called memory, all doing different things: context, RAG, episodic, semantic, and why agent memory is still the messiest, most unsolved layer of the stack. I am Ani. Let us open the box. Video 4 gave the agent hands, tools, schemas, the 4-step tool loop. Now, we have to give the agent history, because the loop from video 3, the tools from video 4, they are useless if the model can never remember what happened 3 iterations ago or 3 sessions ago. Memory is not a separate module you bolt on. It is what the loop reads from before every iteration and what it writes into after every tool call. This whole layer is about how you keep useful things around. The puzzle for today. Every single time you have read in the agent remembers you across sessions, one of 4 wildly different things was doing that work, and the frameworks conflate them constantly, which is a big reason why does my agent forget is one of the top 3 questions asked on RAI agents. If you understand what the 4 flavors of memory actually are, you can debug your agent instead of just wishing it worked better. Today we untangle them, one at a time. Today's 3 beats. First, the 4 flavors of agent memory, one at a time: context, RAG, episodic, semantic. Second, why RAG does not just replace the context window. This is the most common misconception. Third, the honest state of the art. Agent memory is still the messiest layer. What is coming in Lecture 3 to help? Beat 1. Flavor 1. Context. Also called the context window. It is the model's working memory. Everything the model can see on this single turn. Your prompt, the system prompt, the tool schemas, the transcript so far, all of it fits into the context, bounded by tokens. Claude 5 Opus is roughly 200,000 tokens. Gemini 3 Pro is 2 million. Sounds huge until you fill it. A modern coding agent will fill a 200,000 token context window in about 40 tool calls if you are not careful. When it fills, the oldest turns drop off. That is why your agent forgets the earlier parts of the same session. Flavor 2. RAG, Retrieval-Augmented Generation. Lewis and colleagues at Facebook, AI Research, named this pattern in 2020. You have a big pile of documents, way too much to fit in the context, so you embed all of it into a vector database. When a new question comes in, you embed the question, find the top n most similar chunks, and paste only those chunks into the context window. The model answers from just those chunks, instead of the whole corpus. That is RAG. In one sentence, retrieval turns a huge corpus into a small relevant context. Flavor 3. Episodic memory. This one is agent-specific. Every past run of your agent, every full transcript of a session, from start to finish, gets logged and can be queried. So if you ask the agent last Tuesday to book a flight to Tokyo, and today you ask, what did I book last week? The agent goes to the Episodic store, pulls up Tuesday's transcript, and answers. Episodic is not about facts. It is about events, runs, sessions, traces. Think of it as your agent's diary. LangGraph calls it thread state. Anthropic Agent SDK calls it conversation history. Same idea. Flavor 4. Semantic memory. This is long-lived facts. Your name is Bay. You prefer terse answers. Your co-author is Priya. Your paper is about protein folding. Those are not events, they are enduring truths about you. Semantic memory stores those, usually in a key value store or a small vector database, and the agent looks them up at the start of every session and injects them into the system prompt. That is when the agent remembers me across sessions, usually means when a product claims it. Semantic memory is what makes personalization work. Beat 2. Why RAG does not just replace the context window. This is the most common misconception. Naive intuition. If my context fills up, just ragify everything, retrieve relevant chunks. Done. That fails in two ways. 1. RAG retrieves the top-end, most similar chunks. Similarity is not completeness. You can miss the one crucial detail that the embedding did not think was similar. 2. RAG is stateless per query. It cannot remember that in this session you already discussed a related topic. Context can. So the honest answer is, you use both. Context holds the current session. RAG pulls in the wider corpus. They complement each other. They do not substitute. Concrete example. You ask your agent summarize how our billing logic changed since last quarter. Bad approach. Dump the whole codebase into a 2 million token context. Slow, expensive, model gets lost. Also, bad approach. RAG the top 10 chunks about billing. Might miss the crucial commit from July. Actual approach. RAG for the billing files. Put them into context. Then USE the context to hold the running summary and the model's chain of thought as it works through them. Retrieval brings in the right stuff. Context holds the working material. That split is how modern coding agents actually run. Beat 3. The honest state of the art in 2026. Agent memory is the messiest layer in the whole stack. There is no consensus on how to combine the 4 flavors. Every framework does it differently. LangGraph has thread state and its own memory nodes. Llama Index has a whole memory sub-package. Anthropic Agent SDK has message stores and memory tools. And the results are mixed. Agents forget things they should remember. Agents remember things they should have dropped. Personalization is inconsistent. This is a live research area. What is coming to help? Lecture 3 has 2 full videos on memory patterns. Summarization loops. The agent periodically rewrites its own transcript into a smaller summary, freeing context. Hierarchical memory. Recent stuff in fast context. Older stuff summarized. Oldest stuff archived to RAG. Memory-augmented reasoning. The agent explicitly writes to semantic memory when it learns a fact. These are patterns, not settled solutions, but they help. And they all live at the intersection of the 4 flavors we just met. One honest piece of practical advice. If you are building an agent right now, do not try to solve memory before you have shipped anything. Start with just context, the current session, and see how far that gets you. Add semantic memory when a user complains it does not remember my name. Add RAG when a user complains it does not know about my documents. Add episodic when a user complains it does not remember what we did last time. Ship, wait for the complaint, then add the specific flavor that answers it. That is the whole discipline. 3 takeaways before the quiz. 1. Agent memory is 4 things, not 1. Context is the working memory. RAG is retrieval of relevant chunks from a big corpus. Episodic memory is past run traces. Semantic memory is long-lived facts. Different mechanisms, different failure modes, all called memory in the marketing. 2. RAG and context are complements, not substitutes. RAG brings in the right stuff from a big corpus. Context holds the working material of the current session. Every real coding agent uses both, together. 3. Memory is the messiest layer of the whole stack. Ship with context only. Add each other flavor when a user complaint tells you which one is missing. Lecture 3 has the deeper patterns. Quiz 1. What are the 4 distinct flavors of agent memory? A RAM, SSD, HDD, tape. B. Context, RAG, episodic, semantic, working memory, retrieved chunks, past runs, long-lived facts. C. Short-term, medium-term, long-term, permanent. Or D. Cache, buffer, queue, store. B. Memorize this 4-way split. Context is the token window. RAG is retrieval from a corpus. Episodic is past runs, your agent's diary. Semantic is long-lived facts about the user or the domain. When a marketing page says memory, it is doing one of those 4. Knowing which one lets you debug your agent instead of just wishing it worked. Quiz 2. Why does RAG not just replace the context window in an agent? A RAG is slower than context. BRAG retrieves top-end similar chunks, relevant not complete, and is stateless per query. Context holds the current session in order. They complement each other, not substitute. CRAG only works with GPT models, or DRAG has no failure modes. B. Relevance is not the same as completeness. RAG can miss the one crucial detail its embedding did not score as similar, and RAG has no memory of what the current session has already discussed. Context has that. Real coding agents use both. RAG brings in the right stuff. Context holds the working material. Quiz 3. What is the honest practical advice for adding memory to a new agent? A. Add all 4 flavors up front so you never have to touch it again. B. Start with just context, the current session, and add each other flavor only when a specific user complaint tells you which one is missing. C. Rely entirely on RAG and skip context. Or D. Only use semantic memory because it is the most useful. B. Memory is the messiest layer of the stack. Upfront over-engineering is how agents end up over-remembering the wrong things and under-remembering the important ones. Ship, wait for the complaint, add the flavor that answers it. Same discipline as React from video 3. Default, measure, patch. Back to the puzzle. Do AI agents actually reason? After 5 videos, we know they think in English tokens, act through JSON schemas, and remember through 4 different mechanisms, none of which are as good as human memory. That mismatch, a model that can reason within one window but does not automatically carry insights across windows, is a major reason the answer to the puzzle is going to be nuanced. 5 down, 25 to go. Next time, the L1 closer. We have covered the model, the loop, the tools, the memory. Video 6 assembles all of it into one picture. The agent stack: model, prompt, tools, memory, loop. 5 layers, bottom to top. One diagram you can pin to your monitor and never have to relearn. Hit subscribe.